We shall see the next problem. A pitot static tube is used to measure velocity of water in a pipe. The stagnation pressure head and static pressure head are 6 meters and 5 meters respectively. Calculate velocity of flowing water assuming the coefficient of tube is equal to 0.98. This is a very easy problem, but you have not been familiar with the terms stagnation pressure head and static pressure head. So let us see that first. H, that is differential head is equal to stagnation pressure head minus static pressure head. So this is the equation for or equation connecting H and stagnation pressure head and static pressure head. This is something that is not in your syllabus, but it's better you understand these terms. If a question comes, you should be able to attempt. So let us write velocity equal to CV root 2GH. CV equal to 0.98 into under the root of 2 into 9.81 into 6 minus 5. The answer is equal to 4.34 meters per second. It's a very simple problem. The only issue is understanding or remembering this equation. So try to remember that differential head H is equal to the difference between stagnation pressure head and static pressure head. We shall move to the next problem. This is a very interesting problem. A submarine moves horizontally in sea and has its axis 15 meters below seawater. A pitot tube is placed in front of the submarine and along its axis is connected to two limbs of U-tube manometer. Difference of mercury level is found to be 170 mm. Find the speed of submarine knowing that the specific gravity of mercury is 13.6 and the seawater is 1.026 with respect to fresh water. I wish to read the question once again. A submarine moves horizontally in sea and has axis 15 meters below the seawater. A pitot tube is placed in front of the submarine along its axis and is connected to two limbs of a U-tube manometer, and difference of mercury level is found to be 170 mm. Find the speed of the submarine knowing that the specific gravity of mercury is 13.6. Okay, let us draw the figure. After that you will be able to understand more. So this is the top surface, and here we have a submarine. I'm going to draw it like this. You have the submarine. The axis of the submarine is 15 meters below the top surface of seawater, and a pitot static tube is connected in front. So the pitot static tube, I am going to draw the pitot static tube. I'm sorry, I don't know what I'm trying to draw. This is our pitot static tube. Now the seawater will be entering this pitot static tube, and a U-tube manometer is also connected to this pitot static tube to measure the H value. Now we have to find out the velocity of submarine. So we can consider that the velocity with which the submarine is moving forward will be equal to the velocity with which fluid is entering the pitot tube. We can consider like that. So the velocity with which submarine is flowing will be equal to the velocity given by the pitot tube. Okay, so the pitot tube is used to measure the velocity of flow of fluid. The fluid will be fluid is actually static. I hope you all know that seawater is actually static. The currents and all those things are there, but for reference, let us consider it as a static. So when the submarine is moving through a static fluid, the velocity that the pitot tube gives is actually the velocity of the submarine. It's not actually, the fluid is stationary and the pitot tube is attached to submarine. The submarine is flowing, so the pitot tube will give some velocity, and that velocity will be is that of the submarine. Okay, so let us write the equation. CV equal to, sorry, not CV, velocity is equal to CV root 2GH, CV root 2GH, and H is equal to X into SG by S0 minus 1, or X into 1 minus S0 by SL. Here Sg is equal to, the manometric fluid is mercury, so the Sg is equal to 13.6, and the fluid in the pipe is seawater, and the specific gravity is 1.026. I got that from here. So what you have to remember is that the velocity given by the pitot tube is actually the velocity of submarine. The fluid, the seawater is static and the submarine is flowing, and the pitot tube is attached to the submarine. So the velocity that pitot tube gives is actually the velocity of the submarine. That's the only thing that you need to remember. So we will have to use this equation, because if you use this equation, the value of H will be negative. Therefore V is equal to CV, that is CV, the CV value is not given, so let us take CV as 1, since CV value is not given, into 2 into 9.81 times X, that is 170, 0.17 times 13.6 by 1.026 minus 1. I'm doing this in one step. Therefore V is equal to 2.98. V equal to, let me take my calculator, 2.98 into 0.17 into 13.6 divided by 1.026 minus 1, bracket close, into 1 will be equal to 6.39 meters per second. It's a very simple question, and there's one interesting thing. This value has no significance in solving the problem. This value, that 15 meter, has no practical significance. Okay, I hope it is clear to you. If you have any doubts, I hope you all have I hope you all have my number with you. You can call me, you can text me, you can WhatsApp me. Please don't keep the doubts with you. Please do call me and clarify all the doubts. If you want any clarification regarding any topic, you can contact me. Okay, now all the problems related to venturimeter, orifice-meter, pitot tube are done. Now we shall see the problems related to orifices.